Welcome back, everybody. We are on 5.3, day 2, which is solving systems with elimination using multiplication as a part of our elimination. So previously on day 1, when we did elimination, we were just having to add, subtract. We didn't have to manipulate too much. We didn't have to change too many things. Sometimes we had to change the order of a question. But on elimination with multiplication, we are going to have to manipulate the equations a little bit, maybe change some numbers. So we are going to use multiplication to do that. So our steps are pretty much the same. Nothing really changes, but we might have to multiply one or both equations by a number so that the one variable or letter has opposite coefficients. Opposite coefficients just meaning same number, but opposite signs. So a positive 5 and a negative 5, a positive 3 and a negative 3, whatever it may be. So just to give you a quick example, I have this equation here, and I'm asking what can we multiply the x in the first equation to make it the opposite of the x in the second equation, so that they have the same number but opposite signs. So the first equation just has a positive 1x. The second equation has a positive 5x. So what I will need to do is multiply the entire top equation by negative 5 and distribute that in order for us to have a positive 5x and a negative 5x. If I don't want to cancel out the x, I could multiply by 2 to cancel the y values. So there's more than one way to attack these problems, because you can either cancel out x or you can cancel out y. You would just have to multiply by a different number. So you might see x every time to cancel out, and you might be multiplying for x every time, or you might be reading it based off of the individual situations. There is not a preferred way. I don't care if you start with x. I don't care if you start with y. Just multiply by something and cancel something out. So you'll see me do both, just depending on what numbers we're dealing with. I try to go for the smaller numbers. I don't want to multiply by 10. I don't want to multiply by large numbers. And so we're going to try to keep it as small as possible. So looking at example 1 here, what I look for first is, does anything already have opposite signs? Do I have a positive y and a negative y? Do I have a positive x and a negative x? Because then I don't have to deal with multiplying with a negative. Then I am just having to multiply by a number. And so what I see here with example 1 is I have a positive x and a negative 3x. That means all I need to multiply by is 3. So I'm going to take that entire first equation and multiply everything by 3. So I'm going to distribute that 3 to every aspect of my top equation. I do not have to change the bottom equation at all. So when I do this, I'm just going to rewrite it to the side. I find rewriting the whole situation is a lot easier than trying to bounce around within my messy work. So I distribute that 3 on top, and we get 3x plus 3 times 2y is 6y equals 3 times 11 is 33. The second equation does not have to change in this situation. I have a negative 3x, so my x's are going to cancel out. That's what I want to happen. Plus y equals negative 5. From here, I can add down. The 3x and negative 3x are going to cancel out. So now we are just left with our y values. 6y plus y gives me a total of 7y. 33 minus 5 gives me 28. If y'all can hear the train in the background, sorry, it's a little loud. And then from here, I'm going to divide both sides by 7 to get y by itself, and y is equal to a positive 4. So I have my first variable. I have y is equal to 4. From here, I'm going to take that y value, and I'm going to plug it into one of my 2 equations. Again, it does not matter which one you plug it into. You can plug it into either of the original equations. You don't have to multiply. You don't have to use the one that you multiplied. It does not matter to me. Look at whichever one looks easier, prettier for you to handle. I am personally going to do the first equation before I multiplied. So we're going to plug in y equals 4 into x plus 2y equals 11. We'll wavy 11 there. And so that means I'm going to plug in next to that 2. So this is going to say x plus 2 parentheses 4 equals 11. If you use negative 3x plus y equals negative 5, that's fine. I can't stress this enough. You are absolutely allowed to do that. You should get the same number unless you mess up your math. Period. End of story. So I distribute 2 times 4 is 8. So x plus 8 equals 11. And then we subtract the 8 to get x by itself. And x is equal to 3. So our solution, our final answer, is 3. Don't forget which was first. X comes first, and then y, 3, 4. Okay. Looking at example 2 here. I want to go straight into this. I am looking at 3x plus 2y equals 6, and x plus y equals 2. So I do not have any opposite signs. I have no negative signs, no subtraction. So whatever I multiply by, I am going to have to multiply by the negative. So I can either multiply by negative 3 to cancel out 3x, or multiply by negative 2 to cancel out the y with the 2y. It does not matter to me which you choose. Again, if you choose a second number, a different number than I pick, and it's a correct possibility, you should end up with the same answer. So if you want to try something else and see if it works, you're welcome to. And if you end up with the same answer, then you're good. I'm going to multiply by negative 2, personally, on the second equation. So that's going to get distributed to the x, the y, and the 2. So I'm going to rewrite everything. The top equation I am not changing. That's 3x plus 2y equals 6. On the bottom, that gives me negative 2x minus 2y equals negative 4. So here, when we add down, 3x minus 2x just gives me a positive 1x. I like how that worked out. I'm not going to have to divide. I just have my positive 1x already. 2y minus 2y cancels out. Equal sign, 6 minus 4 is 2. So x is equal to 2. Then plug it back in. And I'm going to plug this into x plus y equals 2. So 2 plus y equals 2. Subtract the 2. And y is equal to 0, which is okay because it's still a part of a coordinate. So our answer, our coordinate pair, is 2, 0.